Week 1, lesson 11. For this lesson, you will need a calculator that has a cosine button on it. Okay, so I'll wait. Okay, I'm just kidding. Pause the video, go get your calculator, come back. Okay, so today you're learning something called the dot product. The technical term is the scalar product. Nobody calls it that. Maybe college professors, okay, but most people in general call it the dot product, and it's because of that itty bitty tiny little dot right there and there. All right, now this is how you calculate the dot product, but then this over here is how you can use it. So you'll need both of them, all right? And there's going to be times where instead of having A dot B, you're just going to have this part. And I mean, it kind of depends. Again, it just really depends on what the question is asking. So let's try this first example. All right, find the scalar product of vectors A and B if, so I know the magnitude of A, the magnitude of B, and an angle. So it kind of makes sense to me anyway that I should be using this formula, right? So let's write that formula up and plug in everything that we can. So A dot B is equal to the absolute value, not absolute value, the magnitude of A times the magnitude of B times the cosine of the angle. Okay, magnitude of A was given, magnitude of B was given, and the angle was given. All right, so this ends up being 15 times the cosine of pi over 6. This is where the unit circle comes back in, you guys. Pi over 6 is on the unit circle. So I know that that's rad 3 over 2. Right, maybe you're using your calculator. I did say that you could. So again, plugging that into your calculator and rounding to 3 significant figures. Okay, so from now on, if it doesn't say what to round to, you will be rounding to 3 significant figures. And if you round incorrectly, yes, you will get the problem wrong. So in your handy dandy calculator, go ahead and plug in 15 rad 3 divided by 2, and rounding that correctly, you should get 13.0, 3 significant figures. All right, scooting this up and maybe making it slightly bigger. Here we go. All right, so they've given me these 2 vectors. It says find the angle between, okay, angle between, in both radians and in degrees, rounded to 3 significant figures. All right, so if I'm going to want to find the angle, that means I need this formula. Okay, so let me plug in what I know. Oh, well, crap. I don't know any of that, do I? All right, so let's come over here to the left and see if I can figure these things out. A dot B doing the formula is A sub 1 times B sub 1 plus A sub 2 times B sub 2. Negative 1 plus 3. Okay, so here on the right, this is now a 2. Okay, next I need the magnitude of A, which is the square root of the first one squared and the second one squared, which is the square root of 2. Next, I need the magnitude of B, which is the first one squared and the second one squared. 1 plus 9, so it's rad 10. And this should be enough to plug into my calculator. Right, I'm going to isolate the cosine, which will be 2 over rad 20. Now, when you put this in your calculator, I don't really care which one you do first, just make sure you do both. In radians, if you plug that in and round to 3 significant figures, it's 1.11. Okay, if you change your calculator to degrees and do that same calculation, you should get 63.4 degrees. All right, just make sure you answer both, and both of them have to be rounded to 3 significant figures. All right, next, you'll be able to tell using the dot product whether vectors are perpendicular. All right, and the reason is that if the angle is pi over 2, right? Pi over 2 is 90 degrees. That's angles that meet like this. when you do the cosine of pi over 2, you get a 0. All right, so let's take a look. Are these perpendicular? So that would mean that A dot B would have to equal 0. So let's do this calculation. It's the A sub 1 times B sub 1 plus A sub 2 times B sub 2. That's 15 minus B. Yep, it equals 0. So yes, these are perpendicular. All right, scooting this up. I'll let you read this blue box. We're just gonna, you'll see me use some of these properties in this next problem, okay? So you can refer to that whenever you want. All right, so here it says vectors A and B are given. We know the magnitude of A, the magnitude of B, and the fact that A plus B is perpendicular to A minus 2B. All right, using that, since I know those are perpendicular, that means that the dot product between those two vectors has to equal 0, right? That's what perpendicular means. So let me FOIL, okay? I'm gonna FOIL this. So the first terms become A dot A. The outers are negative 2B dot A. The inners are A dot B, and the lasts are negative 2B times B dot B. All right, now I'm going to use some properties here, right? In fact, I'm going to use that one. All right, this is saying that A dot A is equal to the magnitude of A squared. So this should be the magnitude of A squared. These are like. They're both A dot B's. And combining them, I have negative A dot B. And then over here, this is pretty much the same thing as this, which is minus 2 magnitude of B squared. Okay, so I am going to move this to the other side of the equation, and at the same time, I'm going to plug in some numbers for the magnitude of A and the magnitude of B. So I'm going to have 3 squared minus 2 times 2 squared, and on the other side, A dot B. Okay, so let me simplify a little bit. This is 9 minus 8 equal to, now A dot B is actually the magnitude of A, magnitude of B, cosine of theta. So let me divide both sides, because then I have some numbers to plug in, and this is where my calculator will come in. So simplifying this, 9 minus 8 on the top is 1. Multiplying those magnitudes together, we get 6, right? Because this is a 3 and that is a 2. And then this is where your calculator comes in. Make sure that your calculator is in radians. So if you hit second cosine of 1/6, you should get 1.40.